Hey guys, in today's video, we'll be building the C++ STL vector right from scratch, and we'll be doing that in C. So we'll not be using anything as such. We'll just be playing around with the raw memory, doing a bit of memory management, doing bunch of malloc and realloc, and yeah, let's just see how vector is built. This is going to be a playlist that I'm working on, so this will cover almost all of the STL data structures that we have, and we'll be writing them entirely in C from scratch so that it gives us a much deeper understanding of the data structure, not just so that we can solve problems, but we can also understand what actually takes place under the hood, right? So this is like the first video, and if this goes well, then I'll be working on like other videos as well. So okay, I've created this directory called YouTube. Over here I'll create a directory called data structures. I'll go over here, and yeah, so we want to implement vector. So what is a vector? Vector is basically a dynamic array that we have in C++. So over there we can insert elements, we can like remove elements, and there is no fixed size. As you insert elements, the vector grows. So these are like the benefits of the vector. And also like it's like it has some form of type safety. It's a bit slower compared to arrays because it is actually located in heap memory. We'll come to all of that in a bit. But yeah, so let me just create a file called vector.c, and we will be writing our code in this. Okay, so coming to the understanding of vectors, so like we in C++ STL we have something called as std vector, and this essentially translates to a dynamic array. I mean, it's not a dynamic array in terms of, let's say, the entire concept, but it like very nicely follows it. So this is the data structure that we have in C++ STL, which translates to a dynamic array. So over here we have like a lot of things in vectors. First of all, we have that like constructor type of thing. So this would initialize your vector, right? Then you have things like pushback. So this is used for like pushing a new element to the end of the vector. Then we have things like popback. So this is used for removing the last element from the vector. So let's say I have 1 2 3 4 5, I run popback, so it will remove 5. Then we have back, so this just gives the last element. We have something called as what do we have that? Okay, so we have something called as insert. So in insert we give an index, so we give an index and then we give a value, and then basically in that entire chunk, in that entire vector that we have, in that index it inserts that value. We have something called as erase, if I'm not wrong. So over there we just pass the index and it would essentially remove the element that was there and like shift all of the stuff that was previously there. So let's say I have 1 2 3 4 5, and so it's 0 based indexing 1 2 3 4 5. So at the second index we have the element 3. So if I run erase 2, then it would essentially remove 3 and like trim the array, so it would now become 1 2 4 and 5. Okay, what else do we have? We have erase, we have pushback, we have popback, we have back, we have this initialization. I mean, we can have things like capacity and size. So yeah, let's see. We'll do this on the fly. So what do we require? Firstly, I'll be taking the stdio.h library. So this is the library we'll be using for like taking inputs and printing stuff. Okay, so now what does the C++ STL vector, what does it have? So see, how does a vector operate with like dynamic size of elements, right? So what it does is it has a capacity, and it also has a size. So we should not confuse this. Size is the number of logical elements that is present inside that vector, inside that array, right? This translates to the logical representation of elements. Capacity, this is the memory representation or memory allocation of in bytes. So this capacity is what we have in memory, right? So even if size is 0, capacity may not be 0. This means we have allocated some like form of space for that vector in our memory, but we don't have any logical elements inside that vector. We haven't inserted anything like that, right? We have this thing in C++, like where we can reserve capacities for it, right? So yeah, now how do we like push elements and make sure that we don't exceed this capacity? Let's say my capacity is something like 10, 12. Let's say I am inserting 13 values in there. So what do we do? So what we like, this is the standard, and what std's vector, like, or what the STL also implements is we double the capacity. So let's say it was something like 64, next time it would be 128, right? We double it, and we claim that even though the reallocation is expensive, we are doubling it, we are copying all of the stuff that we previously had to new place, it is very rare, because every time we have to multiply it by 2, right? You can just think, after 64 it's 128, after 128 it's 128 more elements, so that we can get to that 256 mark, right? So this is O of 1 amortized time complexity for pushback. Okay, so that's there. Now let's come to the fun part, right? So firstly, I'll just have a main function over here. I'm not going to do anything as of now over here. What do I require? So in my vector, I'm going to require few things. So my vector needs to have my elements, of course. For this video, I'm just keeping this as integer just to make it easier, but I'm probably going to upload a new video with the generic implementation where you can have the elements in vector of any type. So over here I'm just going to keep this as integer just for the sake of it, but we can actually have like double, float, and we can also have structs, and like, yeah, we can just have any custom data type that we want even in C for the vector implementation. So we just do this using the void pointer. So my vector needs to have my elements, so I need array, and this needs to be a dynamic array, because like I can't have a static array, right? That would be like allocating memory and then I'll be pushing this and all. So I need an array. Then I need a size. This would basically determine like what is the logical number of elements that I have in my vector currently, like 3 elements, 4 elements and all that. And I would be having a capacity. This would basically mean the amount of memory that has been allocated for this vector in my system, right? Okay, so I'll be defining a struct called vector, and inside that I'll be having a few things. We decided that the type is going to be int for this, so this is going to be int, and I'm just going to call this data, and then I'll be having my size, and then I'll be having my capacity. So yeah, this is the definition of my vector. So this is kind of like the structure of the vector custom data structure that we are building, because in C we don't have classes, we don't have any concept of oops if we don't have classes, so we have to make do with this. And this is going to be the pointer that would point to the memory allocation where our elements are actually going to be located. This is the size, so this is going to represent like the logical amount of elements that we have, and this capacity is just as I said, the number of memory like bytes that we have allocated, right? So this is, we can call this the vector struct. Okay, now for the vector we don't have a constructor, because in C we don't have oops, we don't have classes, we don't have a constructor. So we would want to initialize this, right? In C++ we can just use this to initialize this. We can even pass some values to initialize this with a fixed size, capacity, something like that, right? So what we're going to do is we will be creating our own initialization function. So let's have this function called init vector, and this will be getting an initial capacity, right? This will be getting an initial capacity. Now, like in C++, we can do something like this, right? We can do something like this. But in C, we can't do something like this, because this is part of this class, and like this is type name defined, and like these things are not present in C. This is pure C, right? This is just memory, like playing with memory stuff. So we would have to get the vector out of that init function. So we'll have something like this. Our vector will be something like this, and then we'll be calling this, and we'll be passing this. So like you can imagine, this is the type of structure that we'll be having. This means our init vector, it needs to return a vector pointer. And now is the fun thing. So I will be creating a vector, and I would have to allocate memory for this, right? Because nothing can be done unless I allocate memory for this. So I'll be using malloc. So malloc is present in the stdlib stdlib.h. Yep. So malloc is over here, and I'll be passing the size of vector. So what this is going to do, this is not like the size of the vector. This is basically me initializing the metadata of the vector structure. This is used for that. Okay. Now I have to mark the capacity as the initial capacity. Now let's say user gives an input such as 0. I don't want the initial capacity to be 0. I don't want to allocate 0 bytes of memory, because it's very difficult to go from 0 bytes of memory to something else, and also maybe they can just give a negative number. So what I'll do is I'll just put a check. If this is more than 0, then just have this, else just have 1. Cool. And my size will be initially 0, and finally my data. So my data, this is going to be like, this is going to be that initial capacity, whatever I decided, that number multiplied with the size of that type of data that I'm going to hold, which is going to be int. So for int, like the size of int is 4 bytes, and let's say I have given this as 10, so we'll be allocating 40 bytes. Okay, so this will be capacity multiplied with size of int. Great. And after this we can just return this. So this is going to be our init vector. Okay, now let's go for the pushback operation. So the pushback operation is not going to do anything, it's just going to push a value inside that vector at the end of the vector. So we'll be writing that. So also you can see that I would have to pass my actual vector for all of these functions that I write, because there is no oops, I would have to pass this. There is no concept of the this keyword. I have to actually reference it. So yeah, like I would have this, I'll be passing a vector, and then I'll be giving a value, right? Now here's the thing. If I want to push a value to the end of the vector, I will be pushing it at an index. What will be that index? That index will be the one that is marked by the size. So here's the fun thing. This tells the logical size of the element of the array, and also points to the next index where a new element can be be appended, right? So initially my size is 0, so this is like my next index where it can be appended, because I don't have any element, right? Whatever I push will be pushed at the 0th index because my size is 0. So you can think like if my size is 1, then my index is 0, then the next element that I push, it will be at that size index, which will be 1, so it will be going to that 1th index, then the size will be 2. This is like how it operates. Now, so can I just do something like this, where for this array I go to here, I put this value, array size, and then I do this, right? Can I just do something like this? I can, but it's very bad and it's not going to work. Here's why. See, my data, this is having a fixed size, this is having the size which is equal to this initial capacity that I had, right? This is the initial capacity that I had. Let's say my initial capacity was 5 and now I am inserting like the 5th element or the 6th element. At that point it there is nothing like that, right? It's going to give me an error, or it's just going to allocate somewhere in the memory, and it's just going to be very bad. So what we do is we multiply this by 2. Okay, so we multiply the capacity by 2, we increase it as we discussed just a bit before this. So this is the check that we will be doing first. If the size of the array is equals to the capacity of the array, then we would want to grow this. Okay, we want to grow this, great. So this is what we'll be having. We'll be multiplying the capacity of the array 2 by 2. So this will be like my new capacity. I want this to increase, like if it was like 5, then I want this to be 2, 10, right? Then what I want is I want to reallocate all the stuff that was there over here to the, like this was my initial allocation, right? But I have changed this thing, I have changed the capacity, so I would want to update that. So this would be again this, and this is the size that I am looking for. So it will allocate this much amount of memory, it will copy this much amount of the, like all the stuff that I had over here into this memory, and it's just going to return me a pointer in the memory where it points to that like allocation. So let's say my initial stuff was over here, the next stuff can be somewhere here. So it need not be like that the same way, it's not like extending it. What we are doing is we are just copying this somewhere else and we are reallocating this. So this can fail sometimes even, right? And if this fails, this is going to be very bad. So I'll probably put a check that if this is equal to null, then we can print something like memory allocation failed. Cool. And we can just exit. And I hope it doesn't happen. So once this is done, if we didn't go here, then this means this was successful. In that case, we will be marking the data to be 10. Cool. After that, like now I know that this is not the case, so like we have enough space. So for this data over here, I'll be marking the value to be value. You can also do something like this, array of data plus array of size, and dereference it and put this value. These two lines are essentially the same thing, so same thing, just like go no add. So yeah, that was the implementation of pushback. Now let's do popback. So void popback, and again I'm going to get the vector. This time I'm not going to get any values as such, I'm not going to get any parameters. And for this, firstly I'll check if the vector is empty. So if the size is empty, see again all my checking is based on the logical sizing, not on the capacity. The external API, whoever is going to call this vector, is only going to worry about the size, not about the capacity. Capacity is only for us, the internal implementation, not for the people who are using this outside. Capacity is encapsulated. Okay. So now if the size is 0, then I'm just going to return I don't have anything to do. If it is not 0, what should I do? Should I remove the element? Should I do something? Should I remove some memory or no? All I need to do is I just need to reduce the size. That's it. Why this works? Because the next time when I'm going to insert a new element, I have decreased the size. Let's say my size was 5. So the next index where I was going to insert was 5, the fifth index. This means like I had elements from 0 to 4, right? When I decrease the size, the next element that I'm going to push is going to be at the 4th index. So yeah, that's it. And like that will be it. It will get overwritten. So yeah, that is pretty much it for popback. Now a few more functions. What did we discuss? So we have back. So back is going to return this. So I have this back function. So this is back, and we'll be having this vector, and if the size is 0, I will be returning. And just for the sake of this video, let's just consider we have positive elements, so that any kind of bad stuff we can represent using -1. So if the size is 0, we'll be returning -1. Else, if the size is not 0, we will be returning the element that is at the size -1th index. Okay. I think it's very simple till now. Now comes the fun stuff. So next we have this insert and erase, right? So if we talk about the insert, so see, what does the insert do? It would insert a value at a certain index. So let me give you an example. So for the insert, let's say my index was 0, 1, 2, 3, 4, and my elements were 1, 2, 3, 4, 5. I do insert at the second index the element 7. After this, my elements is basically going to be 1, and then at the second index I would be having 7, and I would be having 2, 3, 4, and 5. And you can see like my indexes, they have updated. So 0, 1, 2, 3, 4, 5. Did I do it correctly? No. So I would have to insert at the second index. So sorry about that. So it would be over here. Okay. So at the second index, insert this, and yeah, that is it. So we want to achieve this type of a functionality. I think for pushback it was self-explanatory. Like I have index 0, 1, 2, and I have elements like 1, 2, 3. Then I do pushback 4. Then it would basically be 1, 2, 3, and 4. Cool. Similarly for popback, I'll just give a reference. So the index was 0, 1, 2, and like let's say my elements were 1, 2, 3. So after popback, I'll be having my index as 0, 1, and elements as 1 and 2. And over here also, I'm just going to put the index. Okay. So that is there. And now we have to deal with the insert function. So again, we'll be having the vector, then we will be having the index, and we'll be having a value, right? Now, what are the things that we need to worry about over here? First of all, the index needs to be between this range, right? The index needs to be valid. So So this means if the index is less than 0, this means like if this is a negative element, like negative index, I can't insert at a negative index, right? Or the index is greater than the size of the array, right? So let's say I have an array of size 8, I want to insert at the 10th index. That's not possible, right? So in all of these cases, I'll just return, and before that I'll print a message, index out of bounds. Okay. In any other cases, we'll be doing the insertion. Now here's a fun thing. If I want to insert at the index which is the size, so let's say I have elements like this, and I want to insert at the 4th index, or I want to insert at the 5th index, because the size of the array is going to be 5. This is essentially just a pushback operation, right? So I'll just put that check over here. If index is equals to array size, then just do a pushback on this array with this value and return. We are done. Like, this is taken care of, because this makes sure that for this operation we don't like waste time, or we don't waste any memory or anything like that, because this is just a pushback operation, right? We have to be smart about our like implementation. Okay. So that's done. Next, if this is not the case, right? If this was not the case, in that case I will, like, what is the idea of doing an insertion? Insert means insert at the given index, shift all the elements after the index to right by 1. So as you can see over here, I inserted 7 at the 2nd index, and I shifted all of these elements one place to the right. So that is the meaning. Now I have shifted all of these one place to the right. This means what? This means I used one more extra like block in that memory. So I need to make sure I have that space to take care of this. So for that, I'll again do the same check like here. So if the size of the array is equal to this capacity, then I'm just going to double it. So my capacity I will be doubling, and I'll be getting this. So I'll be getting like a temporary pointer, and I'll be allocating this to the data, and this will be my array capacity multiplied with the number of bytes that I want. That's going to be this. Yeah, I think so. So this will be realloc. Yep. So I would want to reallocate all this stuff, and then if this was equal to null, I would want to print that same message, that memory allocation failed, and I would want to exit, because this is a very bad thing, right? Just like I was not able to allocate memory for this operation. This means like my program kind of crashed. Let's say I want like huge type of thing, I can't just return out of this. I'll just like exit. Okay. If that was not the case, then great, it was successful. I'll just do this. So this is just making sure we have enough space. Okay. Now what do we want? We want to like, what do we want now? Yeah, so we want to insert that element at the index position and shift all of the stuff that was previously there to the right by 1. So you can think of this like this, like okay, if I come from the like behind, then like this was my stuff, right? And let's say this was my index position, and this is the end of the array. Everything to here will move one step here. So this means that stuff that was in the last index, it would go one step ahead, right? Yep. So this means I can have this like from array.size like till this index, and I'll be having this and I minus minus. So for the next index, which will be this, so for the ith, like I'm traveling from behind, so for the ith index I want this to have the value of the I minus 1th index's value, like whatever the value was there, I want this to come here. So this would be array of data of I minus 1, and essentially this would yeah, so this would be the original value that was there in the index, and it would come to that index plus 1. So yeah, I think this is fine. Now I would actually have to, like, this is basically shifting elements one to the shifting elements to the right of index by 1. Okay, and then I would have to do the actual like insert actual like allocation, actual assignment. So for that I'm just going to come here and mark this as this, and we are going to increase the size of the array by 1. And yeah, that was the implementation of this insert function. And the worst case complexity of this is going to be often, because let's say I want to insert at the like top at the front. In that case I would have to shift all of the elements, like all the n elements, so that's going to cost me some time, right? Just like the back, I think I can have the front as well. So this will be this, I just remembered. So again, if the size is 0, then return -1. In any other case I can just return the data and the stuff that was in the initial index of the data. Okay, great. So this was the insert function. Now we have the erase function. So the erase function takes an index. So the erase function takes an index and it basically deletes stuff from that index. So let's say my indexes were 0, 1, 2, 3, 4, and my elements were 1, 2, 3, 4, 5. So if I run something like erase at 3, this means erase stuff in the third index. Or let's say I run erase at 2. This means erase stuff at the second index. This means I want to delete this one. So this would essentially now transform my array into 1, 2, 4, and 5. And my indexes is now going to be 0, 1, 2, 3. So this is the operation that is done by that. So we'll be implementing that. So erase, and again this is going to get this vector. So over here we'll be having this vector, and for the erasing I need to think of a few things. First will be the size. So if the size, not just that, I'll also be having the index, right? So I'll be having the index where I want to like erase that stuff. So I'll be having this check as well, that the index needs to be valid. I'll just copy this code over. Yep. So the index needs to be valid. If this is not a valid index, then like I'll not be able to do anything. I'll not even do anything, right? And if this is a valid index, this means I want to shift all of the stuff, like all of this is my array, this is my index. I want to remove this. I want to shift all of the stuff that is to the right of this one step to the left. So then for int I equals to this index, so from this index and till the size of the array, I would want to shift all of the stuff. I would want to shift all of the stuff that is after the index one step to the left. So that would be array of I will be array of I plus 1, right? Yep. So array of I is going to get this value, and then next is going to get this value, and the next is going to get this value. So like this is going to be the operation, and we want to run this till here because we don't want to get like a out of bound type of thing. And that is it. Like I can just reduce the size, and like whatever element I had in that like position would essentially be removed, in my opinion. So yeah, but if you think like this index, what is this doing? So for the index, like for array of index, this is going to giving me array of index plus 1 and so on and so forth. So that makes sense. I don't know if I should demonstrate this, but yeah, this all makes sense. So we implemented erase, we implemented insert, we have front, we have back, we have pop back, we have push back, we have the initialization stuff. I think it looks good, to be honest. So now it's the time for the real test. Let's see if this stuff actually compiles. So I'm going to do this. There is no compilation error, so I'll be creating a vector. So this will be my vector, and this is going to give an initial capacity of, let's say, 1, right? I'm just giving an initial capacity of 1, nothing else. And now I'll be doing a few things. I'll be doing pushback operations on this vector. I'll be like pushing value 1, then 2, then 3, then 4, then 5. So I'll be having this 2, 3, 4, 5. Yeah. And also I would require this free vector. So the free vector is going to basically free all the memory. See, whenever you are allocating memory, malloc, it gives you, like, C trusts you, malloc trusts you. They give you the power to allocate stuff directly in the memory. So if you are doing that, then you have to be honest with C. If you allocate something, you have to take responsibility of it, and you have to free this. So if this is like null, I'm not doing anything. But if this is actually present, then firstly I'll be freeing the data that it was having, then I will be freeing this thing entirely, because we don't have constructors and destructors in C. We don't have classes, again, we don't have oops. So yeah, and I'll just create one more function called print vector. Over here I'm going to get this vector, and we'll be like printing the entire vector. And so printf element at index %d is %d, and over here this will be I, and this will be array of data of I. Cool. Let me just add a new line. Yeah, and let's just print this vector. So let's just print this. So we'll be printing this vector. Now after this, like it should basically look something like 1, 2, 3, 4, 5. After that, let me do a pop back operation. So I want to do a pop back, and then it should be 1, 2, 3, 4. So I'll do pop back, and then I'll be printing this again, right? And yeah, let's test this out once. So that is there, and if we do this, we can see element at 0 is 1, 2, 3, 4, 5, and then we see element at 0 is 1, 2, 3, and 4. Great. Let us test the